Ever needed to combine multiple FastMCP services while maintaining clean separation between their components? We'll demonstrate how import server asynchronously copies tools and resources from one server to another with optional prefixing to prevent naming conflicts. You'll see the exact naming rules for both prefixed and non-prefixed imports, including how the most recently imported server takes precedence when conflicts occur, and why this async operation requires explicit asyncio run setup before starting the main server.
From FastMCP, import FastMCP. Import asyncio. Hash define subservers. Whether MCP equals FastMCP. Name equals weather service. At weather MCP, tool. Def get forecast city SDR, dict. Get weather forecast. Return city forecast, sunny. At weather MCP, resource. Data //cities /supported. Def list supported cities, list SDR. A list cities with weather support. Return London, Paris, Tokyo. Hash define main server. Main MCP equals FastMCP. Name equals main app. Hash import subserver. Async def setup. Await main MCP, import server. Weather MCP prefix equals weather. Hash result. Main MCP now contains prefixed components. Hash tool, weather get forecast. Hash resource, data // weather /cities /supported. If name equals main. Asyncio run setup. Main MCP run.
This demonstrates server composition through two distinct integration patterns: static reference copying via import server and dynamic runtime delegation via mount. The import server method performs an asynchronous one-time copy of all components from a subserver into the main server, optionally applying prefix-based namespacing to avoid conflicts, while mount establishes synchronous live links that reflect runtime changes in the subserver. The key technical distinction is that import server requires, await, and creates fixed copies during the import operation, while mount operates synchronously and maintains dynamic references. The static approach works by copying components exactly as they exist at the moment of the import server call, with the main server maintaining either prefixed versions or original names when no prefix is specified. For example, a tool named getForecast becomes weatherGetForecast with prefix weather or remains getForecast when imported without a prefix, while resources follow the same pattern with URI paths like data // weather /cities /supported, or keep their original data // cities /supported URIs. When multiple servers share the same prefix or no prefix, FastMCP's conflict resolution ensures components from the most recently imported server take precedence, providing deterministic behavior. This composition model enables modular architecture by letting developers build specialized servers that combine into unified interfaces without tight coupling. The static import server approach is ideal for performance-critical scenarios where you need predictable behavior at runtime, while mount supports real-time updates across server boundaries when dynamic flexibility is required. The asynchronous nature of import server explains why the example uses asyncio run setup before main MCP run, while mount would operate synchronously without requiring a wait. Let's break it down.
From FastMCP, import FastMCP. Import asyncio.
Imports FastMCP for creating modular microservices with composable tools and resources, and asyncio to handle the framework's asynchronous server composition. The import server operation is async, requiring asyncio run setup, while mount, its dynamic counterpart, is synchronous, a key technical distinction in FastMCP's composition model. This setup enables hierarchical service integration, where servers reference each other's components while maintaining independent development. Without a prefix, tools and resources retain their original names, e.g., get forecast, data//cities/supported. With a prefix like weather, they become weather get forecast and data//weather/cities supported. Conflict resolution follows last import wins. Components from the most recently imported server take precedence.
Hash-defined subservers. Whether MCP equals FastMCP. Name equals weather service.
This creates a FastMCP subserver instance named weather service that will contain related tools and resources. Subservers act as modular containers that can be independently developed, then later composed into parent servers. The pattern enables clean separation of concerns while maintaining a consistent FastMCP interface across all components.
At Weather MCP, tool. Def get forecast city SDR, dict. Get weather forecast. Return city forecast, sunny.
The @weather MCP tool decorator exposes this function as an AI callable endpoint in FastMCP's service registry. It automatically generates a typed interface from the function's signature and docstring, enabling AI models to discover and invoke the tool with proper input validation. This pattern maintains clean separation between implementation and interface while ensuring type safety during remote execution.
At Weather MCP, resource, data//cities/supported. Def list supported cities, list SDR. A list cities with weather support. Return London, Paris, Tokyo.
The @weather MCP resource decorator exposes this function as a static data endpoint at data//cities/supported. FastMCP's resource system serves these as structured data through the data// protocol, enabling consistent cross-service discovery. Without a prefix during import, this resource remains directly addressable at its original URI, maintaining predictable access to the supported cities list.
Hash-defined main server. Main MCP equals FastMCP. Name equals main app.
This creates the central FastMCP server instance that will aggregate other servers through composition. The name parameter identifies this as the main coordination point, while the constructor prepares it to receive imported subservers via import server. This establishes the root server that will expose all prefix tools and resources from imported servers under a unified interface.
Hash import subserver. Async def setup. Await main MCP, import server. Weather MCP prefix equals weather.
This async setup function imports the weather subserver into the main server using import server, which creates static references to all tools and resources at call time. The prefix parameter namespaces all imported components. Tools become weather get forecast and resources become data//weather/cities/supported. While omitting it preserves original names exactly like get forecast and data//cities/supported. Unlike synchronous mount for dynamic runtime delegation, import server is asynchronous and establishes permanent references, requiring asyncio run setup before main MCP run. In naming conflicts, components from the most recently imported server take precedence.
Hash result. Main MCP now contains prefixed components. Hash tool. Weather get forecast. Hash resource. Data//weather/cities/supported.
The import server method asynchronously establishes static references to all tools and resources from another FastMCP server with optional prefixing. When called with prefix equals weather, it creates prefix names like weather get forecast for tools and data, / whether /cities /supported for resources. Without a prefix, components retain their original names exactly, get forecast. Data / cities /supported. This differs from the synchronous mount method, which enables dynamic runtime delegation and allows adding tools after the initial composition. When name conflicts occur, components from the most recently imported server take precedence during resolution.
If name == main. Asyncio run setup. Main MCP run.
The name guard ensures the server only starts when run directly. Asyncio run setup executes the asynchronous import server operation that statically binds the weather subserver's components under the weather prefix, unlike synchronous mount, which enables dynamic runtime delegation. This creates fixed references where tools become weather get forecast and resources move to data / whether /cities supported, with the most recently imported server taking precedence during conflicts. FastMCP server composition. The import server method asynchronously establishes static references to another server's components during the import operation, while mount synchronously creates dynamic runtime delegation links that reflect live changes. Components maintain their original names when no prefix is specified, but when conflicts occur between servers sharing the same prefix, or none, the most recently imported server's components take precedence.
The reference that never changes points to what changes constantly.